welcome back to the channel. In our last lesson, we saw the circle and lines touching the circle at two different points. In this lesson, we'll see the circle and the tangent. Now, the question we will use is a circle has an equation. The equation is x minus 2 squared plus y minus 6 squared is equals to 100. Now, we should verify first. Question A says we should verify that the point P, which is at 10 and 0, lies on C. Now, for this point to lie on C, that means if this is a point P, which is at 10 and 0, it must satisfy this equation. That is, if I have 10, the x value for P is 10 minus 2 all squared plus y, which is 0, minus 6 all squared must equal what? 100. So that this is the same thing as 10 minus 2, that's 8 squared, plus 0 minus 6, that's minus 6 squared, which is the same thing as 64 plus 36. And obviously, 64 plus 36 is the same thing as 100. So the point P at 10 and 0 lies on this circle. And the second part of the question wants us to find an equation of the tangent to C at the point 10 and 0, given your answer in this format. Now, to find the equation to this tangent, the first thing we want to do is between the tangent and the center, there's a radius. And the center of this circle is easier for us to find this point. So that from x minus 2, let's take that to be x minus 2 is equal to 0, and that x is equal to 2. And from y minus 6, that will be equal to 0. We know that y is equal to what? 6. So that the center of this circle lies at 2 and 6. It means the center is at 2 and 6. Given that the center is at 2 and 6, and it touches this point 10 to 0, we can conveniently find the gradient of this radius. If I now get the gradient of this radius, I know that my tangent, which is the equation I am looking for, which is the line of which equation I am looking for, is also perpendicular to the radius. So I can use the condition of perpendicularity to now solve for the equation of this tangent. Let's get started with it. First, let's find the gradient m1. Let's call this m1 for this radius. So that m1 will be the same thing as y2 minus y1 over x2 minus x1, which is equal to 6 minus 0 over 2 minus 10, which is equal to 6 over minus 8. Obviously, this is 3 over 4. 2 here is 3, 2 here is 4. That's the same thing as minus 3 over 4. Now, if m1 is the same thing as minus 3 over 4, from my condition of perpendicularity, for m1, m2 should be equals to minus 1. So that m1 is minus 3 over 4. Now, this implies that my minus 3 over 4, m2, is equals to minus 1. m2 obviously is equals to minus 1 times 4 over 3 negative. So that m2 is the same thing as 4 over 3. Now, if m2 is 4 over 3, that is, m2 is a gradient of this tangent, m2 here is 4 over 3, then I can begin to define the equation for this target. That will be y minus y1 over x minus x1 equals to. Now we're saying y minus 0 over x minus 10 is equals to 4 over 3. Now that's the same thing as saying y over x minus 10 is equals to 4 over 3. Now I can cross multiply. So that 3y will be the same thing as 4 into x minus 10. Obviously, 3y is equals to 4x minus 10. Let's create space. Don't forget that my examiner wants us to render our equation in this format: ax plus by plus c equals 0. Now, so we just interpret. I have 3y is equals to 4x minus 10. Let me just create space upwards here. So that my 3y now, we have 3y equals 4x minus 10. My 3y minus 4x plus 10 equals 0. Let me rearrange it again. Minus 4x plus 3y plus 10 equals 0. Here is a required format. So with this, I hope you understand how to work with tangent of a circle and how to find a point that lies on a circle. Thank you for staying with us, and see you in our next class.